Hi guys, in today's lesson we are going to have a look at the discriminant. So before explaining what the discriminant is, what I want you to remember is the quadratic formula, which is over here on the right. And we used that earlier on in the year and we've used it quite a few times this year. So this is our quadratic formula. So x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Now if we remember that formula, we didn't need to memorize that. That came to us on the HSC formula sheet. We just need to know what it represents and how to use it. So if we remember what it does, it actually finds our values of x or our zeros or our roots for a quadratic equation. It's a solution finder for our quadratic equation. So if we don't want to factorize or can't factorize a quadratic by hand, remember factorizing means when we put our quadratic of the form ax squared plus bx plus c equals 0. Remember when we factorize that and we find how to pop that into brackets so that we multiply to that last term and we add to the term in front of the x? If we can't do that, then we can often just use the quadratic formula to do that. And that's going to be part of our discriminant today. So have a look over here on your sheet. So we've got the quadratic formula again, x equals minus b plus or minus the square root of, and under that where we normally would put the square root of b squared minus 4ac, we've got a triangle. That triangle is our discriminant. The discriminant is the piece of our quadratic equation that goes under the square root sign. It's b squared minus 4ac. Now let's remember what b squared minus 4ac is. So let's go back over to the quadratic equation that I wrote down over here, ax squared plus bx plus c. Remember, that's our general form of a quadratic equation. So let's see if we can remember, I'll see if you can remember what a, b and c stand for. So a is always the number out the front of the x squared. B represents the number out the front of x, and c is always the constant term that has no x part involved with it. Okay, so that's how we're finding our b squared minus 4ac, and this is called our discriminant. Let's highlight that, and I'm going to get you on your sheets to write that up the top. The discriminant we write as a triangle, and it is equal to b squared minus 4ac. Okay, let's have a look at the points that we've got underneath here. The first point says always calculate the discriminant first when finding the zeros of a quadratic. I don't think you need to always do it, but it's a really handy tip and quite often very helpful, and we'll have a look at how that can be helpful now. The blue, the green and the yellow. You need to know each of these things and you need to understand what's happening, and we're going to look at what they mean and how we can use them. So we can calculate the discriminant for our quadratic. So we calculate b squared minus 4ac and we have a look at what's happening with it. If our discriminant is bigger than 0, what that means is there are two zeros or two roots or two solutions to our quadratic equation. We can also think of it as two places that our quadratic cuts the x-axis. Why that happens is, think of what's happening in our formula here. If b squared minus 4ac, or the part under the square root sign, is positive, then we have a value. So we're going to end up with two answers to x, I guess, minus b plus our part under the square root sign, and minus b minus our value under the square root sign all over 2a. So we're going to end up with two zeros if our discriminant is greater than 0. We would say that our zeros we're going to call our roots, and we can also call it where it cuts the x-axis. So we're finding that with this topic there's a lot of new language or a lot of different ways we can explain the same thing. So let's have a look at what that means. So two zeros, we quickly draw ourselves a little x and y axes here. I'm just going to pick two random points on our x-axis, and our graph might look like this, or it might go upside down, and those points would be in different spots. But that would happen when our discriminant is greater than 0. We'd have two different solutions. We could also call that those solutions, or our zeros or our roots, as unequal roots. Okay, they're unequal because there's two values that are different. Our value here is a different value to here, so we'd call them unequal, but we'd also call them real roots. Okay, the numbers are not unreal, they're not imaginary, they're real numbers. So they're all different ways that could be asked of you in a question. And that's our discriminant greater than 0. What happens if our discriminant is equal to 0? Let's think of what would happen in the quadratic formula there. That would mean that our part under the square root sign, or our discriminant, our b squared minus 4ac, does not exist. So we would only end up with one answer. We would have x is equal to minus b over 2a. There'd be no plus or minus anything because that would be 0. So what would happen when the discriminant is 0? There is only one 0 or one root or one place where it cuts the x-axis, because 0 is the only square root of 0. And in this situation, the x-axis is a tangent to the graph. So let's have a look at a picture of that. So I've just moved over to the side here and I've drawn myself another x and y axes here. So we're looking at what would happen if our discriminant is equal to 0. We said we would get one value, or one 0 or one root. They would also be called equal roots and they'd be real roots. But what the graph would look like would be something like this. Or it could be upside down, like that. And that point could be anywhere along the x-axis. But there's one point, one value. We call them equal roots because if it was, for example, 3, and we got two answers, we'd have 3 and 3, which is the same point. What the question could also say to us is, it says, and in this situation, the x-axis is a tangent to the graph. Now, we haven't done calculus yet where we look at tangents, but that will come along soon enough. But what a tangent is a line that touches at only one point. So in that case, it means the x-axis is a tangent. It only cuts at one point. So that's an example of the discriminant equal to 0. Let's move across here, and there's one last one. The discriminant less than 0. Now this is an interesting one, this one. So let's have a look at what happens. If our discriminant, or our b squared minus 4ac, is less than 0, what we're getting is a negative number. We're getting a negative number under the square root sign. Now, if you were to pop a negative number on your calculator, and I might just grab my calculator now here. If I was to pop, for example, to move that up a little bit so we can see it. There we go. If I was to pop, for example, minus 9 under the square root sign. So there's my square root sign, minus 9. I've just picked any random number and press equals. What I get is a math error. Let's try another one. Square root of minus, 78 equals. I get a math error again. Okay, so I'm trying to take a square root of a number or a discriminant value that's less than 0. I get a math error. The reason being is we, at this point in our maths career, cannot take the square root of a negative number. So what would happen is there would be no solution that is real. No real solution, and we would say the discriminant less than 0, there are no zeros or no roots because negatives don't have a square root for us at the moment. We would say we would have an unreal solution. Okay, where our discriminant greater than 0 and equal to 0 were real, here we can't take the square root of a negative, so we'd have an unreal solution. And we'd say there are no zeros, or there is no place where that graph can cut the x-axis. Let's have a look at what that looks like. So I'm going to zoom over to my graph over here that I did before. What we'll do is we'll remove that one and we'll have a look at what it means for us now. So I've got an x, so I've got a y, and I'm saying now my discriminant is less than 0. So although we don't have any zeros or roots, we still have a parabola, but what's probably going to happen is it's probably going to look like this. Okay, or it might look like this. So where our vertex is, or our little turning point here, it just doesn't sit on the x-axis, or it doesn't pass through the x-axis. Okay, there's no roots, it doesn't cut the x-axis. And so what we say is there are no zeros. Okay, so you need to understand, I think understanding is a little bit better than memorizing it. We need to know these and we need to understand these, but the best way to do that is to think about what's happening under the square root sign and what that means for each of those. The first two are real. The last one is unreal. The first one here is unequal. The second one is equal. And the third one has no roots. The second one also could be asked as touching as a tangent. So there's a few different ways we can ask it. Remembering a zero or a root is a place where it cuts the x-axis. Let's have a look at a question. Okay. Now I've worked through this one in class already today, so there's already some solutions up there, but the question says, use the discriminant to find the number of zeros of y equals 5x squared minus 20x plus 21. First of all, to use our discriminant, which is b squared minus 4ac, we need to come up with an a, which is the number out the front of x squared, which is 5. B is minus 20, it's out the front of x, and c is 21. Pop those straight into our formula. Our discriminant, b squared minus 4ac, in it goes, minus 20 squared minus 4 times 5 times 21. Pop that in and we end up with minus 20. Minus 20 is less than 0. Pop up and have a look what happens again. When the discriminant is less than 0, we have no zeros. And we have unreal solution. Okay, we could draw that as well if we wanted. We're not going to do that right now though. What I also want to do is jump over in our OneNote to where we have got 310, the discriminant on the side, and have a look at a couple of questions in here as well. The one in particular that I want to have a look at right now is 3 and 4. Those are from our textbook questions. Okay, question 3 says, find the value of p for which the quadratic equation x squared plus 2x plus p equals 0 has equal roots. Okay, we need to go back. We need to have a look at when we get equal roots. What happens with the discriminant? The discriminant would be equal to, to b squared minus 4ac. It's either going to be greater than 0, equal to 0, or less than 0. If we had equal roots, that means we have two roots that are the same. So that's the second one where it's equal to 0. In this case, on our first one, a is 1, b is 2, and c is p. Let's pop that in and see what we get here. B squared is 2 squared minus 4 times 1 times p equals 0. 2 squared is 4 minus 4p equals 0. Let's rearrange that. Let's add 4p to both sides. 4 is equal to 4p, so p is going to be equal to 1 in that case. So let's see if we've answered the question. The question says, find the value of p for which the quadratic equation x squared plus 2x plus p has equal roots. We've got the value of p. The equation would look like this. X squared plus 2x plus 1 equals 0. Now, if you want to check what that means, or we'll just have a look at it. Let's see if we can quickly pop that into brackets and factorize it. This is our answer, but I'm just wanting to observe a little bit more about what's happening. So if we were to factorize that, we're looking for numbers that multiply to 1 and add to 2. What would we get? We would get, oops, sorry, it's going to add to 2 there. 1 and 1, plus 1, plus 1. If we solved each of those and set each bracket to 0, solve for x, we'd end up with x is minus 1 and minus 1. Both the same value. Our graph would be cutting the x-axis. We'll have a 0 or a root at minus 1 over here. There's a lot more sketching we can do, but it cuts here at 1, and we could find a little bit more information, but we've got the axis of symmetry down there. And that's a quick look at what that graph would look like.